My talk is called Breaking All the Rules, Unpredictable Response of Georgian Bay Marshes to Water Level Disturbance. McMaster stands on land that's protected by the Dish with One Spoon Wampum Agreement, and the wetlands we sample in Georgian Bay are within the Anishinaabe territory. I seek a new relationship with the original peoples of this land and acknowledge that they are the traditional inhabitants of the lands where I work, live, and conduct research. Georgian Bay is the eastern arm of Lake Huron and is approximately 15,000 square kilometers. This inland sea is widely acknowledged to be one of the least disturbed regions in Lake Huron. So, for instance, in the 1995 Great Lakes Atlas, it's shown to have the least modified land uses, with mostly forested land along the eastern and northern shoreline of Georgian Bay. And according to the Great Lakes Environmental Indicators developed by Nimi et al., eastern Georgian Bay has relatively low stresses related to land cover loss, the human population, and road density. NOAA's digital coast inventory shows that the shoreline of Georgian Bay also has low stresses related to recreation and other human activities. EPA's GLEAM project shows that stress related to Dreissenid invasion is very low, second only to Lake Superior. So overall, all these large-scale indicators have consistently shown that Georgian Bay is in really great condition relative to Lakes Michigan, Erie, and Ontario. Our lab has developed an ecological indicator called the Water Quality Index, the WQI. And this is based on the amount of pollutants that are in the coastal marshes, things like the nutrients and suspended solids that come from human disturbances. We sampled more than 150 wetlands to create this index, and we've applied it throughout the 5 Great Lakes. We have sampled more than 100 wetlands in Georgian Bay alone, and this is more than any other government agency or research lab. And we have independently confirmed that the quality of the coastal marshes in Georgian Bay and in the North Channel are uniformly in very good to excellent condition. And you can see here on this map that all of the very warm colors like red and orange indicate very degraded wetlands, and the very cool colors like the blue and the green are the excellent and very good. And so for some of these wetlands, we have also sampled once every 3 to 4 years. And we've studied them and know how they responded to the water level fluctuations. We know that they are not like any other wetlands in Lakes Erie, Ontario, and Michigan. One of the reasons for their difference is the granite bedrock, which limits wetland development. Lakes Ontario and Erie have shale and sandstone that are easily eroded and can form a thick substrate layer for wetland plants like cattails. Wetlands in Georgian Bay, however, have shallow soils and are often dominated by bulrush, wild rice, and other emergent species. We digitized all the coastal wetlands using 2002 and 2003 satellite images, and we found over 5,000 hectares of coastal marshes in eastern and northern Georgian Bay. Although most of them were very small, less than 2 hectares in size, and are therefore not eligible for wetland assessment by the province. But these wetlands are nevertheless very important habitat for at-risk reptiles and the Lake Huron fish community. And they are also extremely sensitive to water level extremes. Typically, these wetlands are surrounded by rocks and trees, and there is a narrow zone with meadow plant species like sedges and grasses. But during the late 1990s, water levels dropped by more than a meter to very low levels in Lake Huron, and they remained low for 14 consecutive years. We saw a dewatering of many of these coastal marshes, followed by a colonization of meadow species. So from 1999 to 2013, we had 14 years of sustained low. And this appears to be unprecedented when you look at how the levels have fluctuated over the last 100 years. And this has been followed by another 7 years of high levels that are now coming down finally. But we reached a point in 2021 where we had the highest July water levels. So we wanted to know how this water level fluctuation has affected the vegetation zonation in these wetlands. First, I want to explain what I mean by vegetation zonation. The different types of plants in a wetland are adapted to living in different water depths. Most trees and forests are intolerant of any type of flooding, while the meadow species will tolerate some seasonal flooding, for instance, during the springtime when water levels tend to be highest following the snowmelt. The emergent plants have a range of tolerance from fairly wet to always wet, while all of the floating and the submergent species must always occur in or on the water. So water of the Great Lake, in this case Lake Huron, fluctuate annually. The water's edge separates the ecosystem into a terrestrial part that occurs above the shoreline and an aquatic part that occurs exclusively below the shoreline. And the plant species that live in the terrestrial zone include the trees, sweet gale and sedges, cattails, and then in the aquatic, the bulrushes, water lilies, and the pondweed. And during the normal cycle of high and low water levels, there will be no net change in the high marsh, which is above the water, and the low marsh, which is below the water. And during this period of sustained low water levels between 1999 and 2014, there was a net expansion of the terrestrial habitat at the expense of the aquatic habitat. So some of the trees started to move into the meadow zone, and the species of meadow plants moved into the emergent zone. And then the water lilies and the submergent vegetation became very dense and compressed in shallow water. When water levels rebounded in 2014 and then continued to rise to record high in 2021, the meadow zone became flooded and the trees and the shrubs that were growing there began to die out. But they didn't topple as the literature had suggested. Even after 5 years of flooding, the trees and the shrubs stubbornly persisted, forming this novel habitat that consisted of the ghosts of the previous trees and the shrubs. And here are some on-the-ground photos of what the wetlands looked like during 2002 and 2004 after the initial 5 years of low water levels. You can see wetland zones that are pretty much textbook. Another 5 to 8 years after this, you can clearly see how the shrubs and trees have migrated into the meadow zone and how the aquatic habitat has become compressed. And these photos taken between 2016 and 2019 illustrate the novel habitat with the dead and dying trees and the shrubs still standing in 2 meters of water. Knowing that there were these on-the-ground changes, we wanted to quantify this change using satellite images. So we were able to get access to ICONO's multispectral satellite images and then acquired Pleiades images in 2019 and do a change detection. We selected 4 locations for this study, which included Pointe Barrow and Franklin Island, which is above Parry Sound, and Tatanack Bay and Severn Sound below Parry Sound. Weller and Chow-Fraser developed an index to assess the vulnerability of wetlands to water level fluctuations, and these are simply based on substrate slope and exposure to wind and wave action. And I don't have time here to go into the development. When we look at how these wetland sites scored in terms of vulnerability to water level,
Tatanac had very low VI score, and Severn Sound had a very high VI score, while the other two were intermediate. We also noted that Tatanac Bay was the least disturbed by human activities, while Severn Sound was the most disturbed, and the other two wetlands had intermediate disturbances. So what I'm showing you here is the graph with the mean percentage area across these various categories, which include the dead trees, floating vegetation, emergent meadow or shrubs, which we could not distinguish within the satellite image, open water, rocks or barren land, the submergent aquatic vegetation, and trees. And the darker color bar is for high water, and the open bar without any color is the low for low water levels. So not surprisingly, with an increase in water level, the emergent meadow and shrub category, as well as the rock and barren land category, both decreased. Open water in general increased, but it did not do so in any significant statistical manner. The percentage of the submerged aquatic vegetation responded inconsistently, with increases in Franklin and Portobello, but decreased in the other two. And the dead trees category accounted for a very low 1.2% of the vegetation in Tatanac, but increased to almost 7% in Severn Sound. And we also saw no significant change in floating vegetation. Now, the conversion from emergent meadow and shrubs to dead trees was really high, except for Tatanac, which was also very low in terms of the conversion from the trees to dead trees. The largest percentage of the dead trees and the highest conversion from the submergent aquatic vegetation to dead trees occurred in Severn Sound, and the greatest shift in the shoreline for wetlands located in Franklin Island. Now, even though the percentages in terms of aerial cover of dead trees may be low, you can see that it has a very drastic effect on the ecosystem. Here are two photos of the same wetland taken 13 years apart, one during sustained low water levels in 2006, and the other one 13 years later after it became flooded again. And this wetland is undisturbed by human development, but you can clearly see that water level disturbances have created different wetland zonations, and it makes us wonder if this novel vegetation structure has also affected the fish and the wildlife community. Well, we know that with the presence of the dead trees and shrubs, it is almost impossible for us to set the fyke nets properly to survey the fish. And so we know that we have to use different methods to monitor the fish community. We also know that the flooded dead tree zone is currently used by female Blandings turtles during nesting migrations, but we don't know if they were using them during the low water levels because we were not surveying the Blandings at that time. And the literature also predicted that the dead trees should not persist after 3 to 4 years, and yet we still have them after 7 years. So we know that more research is needed to determine the response of wetland to climate change that drives these fluctuations in water levels. And we cannot use the response of these changes based on other Great Lakes because they don't work for Georgian Bay. Georgian Bay has broken all the rules, and it will again. We must continue to conduct research in Georgian Bay for Georgian Bay. So don't believe it. One size does not fit all. I would be remiss if I did not thank Dr. Prabha Rupasinghe, who's presently at U of Calgary, for all the great remote sensing work that she did on this project as a postdoc in my lab. I also want to thank Danny Montocchio and a host of graduate students in the past that are too numerous to name for all the field data collection they did. And I want to also acknowledge funding from MITACS, the Georgian Bay Great Lakes Foundation at McMaster University. And we'll also want to thank Georgian Bay Forever for giving us permission to use the Iconos images for this project. Thank you very much.